Electrical safety in commercial buildings is of paramount importance, and a number of hazards can arise if proper practices are not followed. Open taps, extension cords used as permanent wiring, open light fixtures, and the use of Romex in commercial applications are all significant concerns. Open taps, which involve exposed conductors, present both an electrical shock and fire hazard. The use of duct tape as a means of covering openings is not an acceptable safety measure, as it does not provide adequate insulation or protection. Extension cords, while convenient for temporary use, should never be used as permanent wiring in a commercial setting. These cords are not designed to handle the same load as permanent wiring, and their use can lead to overheating and an increased risk of fire. Open light fixtures, lacking proper covers, expose live electrical components, thereby elevating the risk of electrical shock. Additionally, these fixtures can accumulate dust and debris, potentially causing short circuits. Romex wiring, typically used in residential applications, is not suitable for commercial environments. It lacks the robust protection against physical damage and fire that conduit-based systems provide. The presence of these hazards, in addition to others such as the lack of conduit or metal-clad cable, necessitates corrective actions to bring the electrical system up to code and ensure the safety of the building's occupants. Firstly, conduit or metal-clad cable should be installed for all wiring to provide physical protection and prevent damage to conductors. Secondly, covers should be placed on all open light fixtures to prevent accidental contact with live components and to minimize the accumulation of dust and debris. Thirdly, open taps should be replaced with properly sized and covered junction boxes to provide a safe and secure termination point for conductors. Fourthly, all extension cords used as permanent wiring should be removed and replaced with permanent wiring methods, such as conduit and appropriately rated conductors. Fifthly, appropriate wiring types, such as THHN conductors installed within conduit, should be used for all commercial applications to ensure compliance with electrical codes and safety standards. Addressing these electrical safety hazards promptly is crucial to prevent accidents, injuries, property damage, and potential legal consequences. Regular electrical inspections and maintenance are essential to ensure ongoing safety and compliance with applicable codes and regulations. Understanding electrical safety in a commercial environment begins with recognizing the specific dangers that can arise from improper wiring and equipment. Open taps, for example, represent a direct violation of safety standards. An open tap occurs when electrical conductors are exposed, creating a risk of accidental contact. This can lead to electric shock, burns, or even electrocution. In a commercial setting where numerous people may be present, the consequences of an open tap can be severe. The correct approach involves using junction boxes to enclose and protect all electrical connections. Junction boxes provide a secure and insulated environment for splicing wires, preventing accidental contact and reducing the risk of fire. Extension cords are another common source of electrical hazards in commercial buildings. While extension cords are useful for temporary power needs, they should never be used as a substitute for permanent wiring. Extension cords are typically not rated for the same amperage as permanent wiring, and they can easily become overloaded. Overloading an extension cord can cause it to overheat, potentially leading to a fire. Additionally, extension cords are more susceptible to damage than permanent wiring. They can be easily pinched, cut, or frayed, exposing live conductors. In a commercial setting, where there is often heavy foot traffic and equipment movement, the risk of damage to extension cords is particularly high. The proper solution is to install permanent wiring and outlets to meet the building's power needs. This ensures that the electrical system is properly sized and protected, reducing the risk of overloading and fire. Open light fixtures also pose a significant safety risk. Light fixtures are designed to enclose and protect the bulb and wiring. When a light fixture is open or damaged, live electrical components are exposed. This can lead to electric shock if someone accidentally touches the exposed components. Additionally, open light fixtures can allow dust, debris, and moisture to enter the fixture. This can create a short circuit, causing the fixture to fail or even start a fire. The remedy is to ensure that all light fixtures are properly enclosed and in good repair. This includes replacing any damaged fixtures and installing covers or lenses to protect the bulb and wiring. The use of Romex wiring in commercial applications is another common violation of electrical codes. Romex, also known as non-metallic sheath cable, is a type of wiring that is typically used in residential buildings. It consists of insulated conductors wrapped in a plastic jacket. While Romex is suitable for residential use, it is not designed for the demands of a commercial environment. Romex is more susceptible to damage than other types of wiring, such as conduit or metal-clad cable. It can be easily punctured, cut, or crushed, exposing the conductors. In a commercial building, where there is often heavy equipment and machinery, the risk of damage to Romex is particularly high. Furthermore, Romex is not as fire-resistant as other types of wiring. In the event of a fire, Romex can quickly melt and release toxic fumes. Commercial buildings typically require wiring methods that are more robust and fire-resistant. Conduit, which is a metal or plastic pipe that encloses and protects electrical conductors, is a common choice. Conduit provides excellent protection against physical damage and fire. Metal-clad cable, which consists of insulated conductors wrapped in a flexible metal jacket, is another option. Metal-clad cable offers a good balance of protection and flexibility. Correcting these electrical safety hazards requires a comprehensive approach. Firstly, a qualified electrician should conduct a thorough inspection of the building's electrical system. This inspection should identify any open taps, improperly used extension cords, open light fixtures, Romex wiring, and other code violations. Secondly, a plan should be developed to correct the identified hazards. This plan should include specific steps for repairing or replacing damaged equipment, installing new wiring, and bringing the electrical system up to code. Thirdly, the corrective work should be performed by a licensed and experienced electrician. The electrician should follow all applicable electrical codes and safety standards. After the corrective work is completed, a follow-up inspection should be conducted to ensure that all hazards have been properly addressed. Regular electrical inspections and maintenance are essential for maintaining electrical safety in commercial buildings. Electrical systems should be inspected at least once a year, and more frequently if there are any known problems or concerns. Maintenance should include tasks such as tightening connections, replacing worn or damaged components, and testing safety devices. By addressing these electrical safety hazards and implementing a program of regular inspections and maintenance, commercial building owners can protect their employees, customers, and property from the dangers of electricity. Moreover, failing to address electrical hazards can lead to serious legal consequences. Building owners and managers have a legal responsibility to provide a safe environment for their occupants. If an electrical accident occurs due to negligence, the responsible parties may be held liable for damages, including medical expenses, lost wages, and property damage. In some cases, criminal charges may also be filed. Compliance with electrical codes is not only a legal requirement, but it is also a matter of ethical responsibility. Building owners and managers have a moral obligation to protect the safety of their occupants. By taking steps to ensure electrical safety, they can demonstrate their commitment to the well-being of their community. In addition to the specific hazards mentioned above, there are other electrical safety considerations that are important in commercial buildings. These include proper grounding, surge protection, and arc fault protection. Grounding is the process of connecting electrical equipment to the earth. This provides a path for fault current to flow, which helps to protect people from electric shock. All electrical equipment should be properly grounded in accordance with electrical codes. Surge protection is designed to protect electrical equipment from voltage spikes, which can damage sensitive electronic components. Surge protection devices should be installed at the main electrical panel and at individual outlets that serve electronic equipment. Arc fault protection is a type of circuit breaker that is designed to detect and interrupt arc faults, which are a common cause of electrical fires. Arc fault circuit interrupters, or RFCs, should be installed in branch circuits that serve bedrooms, living rooms, and other areas where people may be sleeping or spending a lot of time. Electrical safety is a complex and multifaceted issue. It requires a thorough understanding of electrical principles, codes, and standards. It also requires a commitment to safety on the part of building owners, managers, and occupants. By working together to identify and correct electrical hazards, we can create safer environments for everyone. The information provided is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for specific recommendations and to ensure compliance with applicable electrical codes. Commercial buildings often have complex electrical systems that require careful planning, installation, and maintenance. Proper design of the electrical system is crucial to ensure that it can meet the building's power needs safely and efficiently. This includes selecting the appropriate size and type of wiring, conduit, and electrical equipment. It also includes designing the system to minimize voltage drop and ensure proper grounding. Installation of the electrical system should be performed by licensed and experienced electricians. They should follow all applicable electrical codes and safety standards. Proper installation is essential to ensure that the system is safe, reliable, and meets the building's power needs. Regular maintenance is essential to keep the electrical system in good working order. This includes tasks such as tightening connections, replacing worn or damaged components, and testing safety devices. Maintenance should be performed by qualified electricians on a regular basis. Commercial building owners and managers should also be aware of the potential for electrical hazards caused by tenants. Tenants may install their own electrical equipment or make modifications to the building's electrical system without proper authorization. This can create serious safety hazards. Building owners and managers should have policies in place to prevent unauthorized electrical work. They should also conduct regular inspections to identify any electrical hazards caused by tenants. Electrical safety training is essential for all employees who work in commercial buildings. Employees should be trained to recognize electrical hazards, use electrical equipment safely, and respond to electrical emergencies. Training should be provided on a regular basis and should be tailored to the specific needs of the workplace. Electrical safety is not just a matter of compliance with codes and regulations. It is a matter of protecting the lives and property of people who work in and visit commercial buildings. By taking steps to ensure electrical safety, we can create safer and more productive environments for everyone. Always remember to turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. If you are not qualified to work on electrical equipment, call a licensed electrician. Electrical accidents can be prevented by following these simple safety precautions. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years and is widely adopted throughout the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring electrical safety. Many local jurisdictions have adopted the NEC as law. Building owners and managers should be familiar with the NEC requirements that apply to their buildings. They should also ensure that all electrical work is performed in accordance with the NEC. There are many resources available to help building owners and managers learn more about electrical safety. These include the National Fire Protection Association, the Occupational Safety and Health Administration, and local electrical contractors. By taking advantage of these resources, building owners and managers can stay informed about the latest electrical safety standards and best practices. Electrical safety is a shared responsibility. By working together, we can create safer environments for everyone. The key to any electrical installation is to consult the National Electrical Code. For example, Article 310.15 of the NEC covers ampacity, the current carrying capacity of conductors. Understanding ampacity is crucial for selecting the correct wire size for a given load. If a wire is undersized, it can overheat and potentially cause a fire. The NEC provides tables that list the ampacity of various wire sizes and types, taking into account factors such as insulation type, ambient temperature, and the number of conductors in a raceway or cable. Overcurrent protection, such as circuit breakers and fuses, is another essential aspect of electrical safety. These devices are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the circuit breaker or fuse trips, interrupting the flow of electricity and preventing damage to the wiring and equipment. The NEC specifies the appropriate size and type of overcurrent protection for various circuits. Grounding is a critical safety measure that helps to prevent electric shock. A properly grounded electrical system provides a low resistance path for fault current to flow back to the source. This allows the overcurrent protection device to trip quickly, interrupting the flow of electricity and protecting people from electric shock. The NEC provides detailed requirements for grounding electrical systems. Bonding is another important safety measure that helps to equalize the voltage between different metal parts of an electrical system. This reduces the risk of electric shock if someone comes into contact with two different metal parts that are at different voltages. The NEC provides requirements for bonding electrical systems. Surge protection devices are designed to protect electrical equipment from voltage surges, which can be caused by lightning strikes, power grid switching, or other events. Surge protection devices divert the surge current to ground, preventing it from damaging sensitive electronic equipment. The NEC recommends the use of surge protection devices in certain applications. Arc fault circuit interrupters are special types of circuit breakers that are designed to detect and interrupt arc faults. Arc faults are dangerous electrical conditions that can cause fires. A size are required by the NEC in certain circuits, such as those that serve bedrooms. Ground fault circuit interrupters are special types of receptacles or circuit breakers that are designed to detect and interrupt ground faults. Ground faults occur when current flows through an unintended path to ground, such as through a person's body. GFCIs are required by the NEC in certain locations, such as bathrooms and kitchens. Electrical inspections are an important part of ensuring electrical safety. Electrical inspections are typically performed by local building departments or by certified electrical inspectors. The inspector will review the electrical installation to ensure that it complies with the NEC and other applicable codes. Regular electrical maintenance is essential for keeping electrical systems in good working order. Maintenance tasks include tightening connections, inspecting wiring for damage, and testing safety devices. Electrical maintenance should be performed by qualified electricians. Electrical safety training is important for all employees who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and the proper use of personal protective equipment. In addition to following the NEC and other applicable codes, it is important to use common sense when working with electricity. Always be aware of the potential hazards and take steps to protect yourself and others.